Members of these sets are also members of set A. Members of any of these sets A1 to A6 are also members of set A. And what we find, the number of members of each of these sets are less than the number of members of set A, having members of which some may be in A, some may be in B, or some may be within A and B. We express that by using Venn diagram like this. These diagrams were used by John Venn Therefore, intersection of two sets or neet of two sets is a set having members which are common to both A and B sets. Next we move to subset and superset. I start here with an example. First of all, I have taken a set A having members A, B, C, then these sets. I have taken set A having members A, B, C. Now we are considering these sets A1, set of A, A2, set of B, A3, set of C, A4, set of AB, A5, set of BC, A6, set of AC. What we find up to this? That members of the sets A1 to A6 are less than the number of members of set A. In these cases, we call A1 to A6 subsets of set A. The meaning is that members of these sets are also members of set A. Members of any of these sets A1 to A6 are also members of set A. And what we find, the number of members of each of these sets are less than the number of members of set A. But the members of any of these sets are the members of set A. In this case, we say that these are subsets of set A. Thus, we can define a subset. A set B is a subset of set A if member of set B are also member of set A. We express that by writing X belongs to B implies X belongs to A. These are set notations. We will be habituated by reading and writing. If X is a member of set B, implies X is member of set A, then we say X is subset, sorry, A is subset of set B, and we denote that by writing A is subset of set B, or we use the symbol A is, this is symbol for subset, also this one symbol of subset. Now you see there are differences between these two symbols. When we use this is actually when number of members of set A, when number of, I have written here wrongly for this example, B is subset of A, when number of members of set B will be less than number of members of set A, then we call B is proper subset of set A, proper subset of set A. But when we don't know the number of members of set B are equal to number of members of set A, then we call improper subset. This is actually used in case of proper subset. But if we don't know the number of members of set B, but each member of set B is also member of set A, then we express that by saying B is improper subset of A and use this symbol. Now already I have taken examples for subsets. Now you see A7, that is same as that of set A. Therefore we can say set A is also subset of itself. Keeping that in mind, we use this symbol. If we don't know whether the number of members of the set are same as the number of members of the given set, then we use this symbol. In case of subset, proper subset, this B set must have at least one member less than the number of members of the original set. Then we treat that as proper subset of the given set. Now, on the contrary, we see that A contains more elements or equal number of elements of each of the subsets A1, A2, A3, A4, A5, A6 and A7. Thus, we say A is superset of all these sets. We express that by writing A1, A2, A3, A7, all are subset of set A. Therefore, we say A is superset of set A and write, express that A is superset of A1, A is superset of A2. A is when subset may have less or equal numbers of members of set A, we write this symbol. If we reverse that, we get A7 is subset or improper subset of set A. Thus, we have discussed about subset and superset. Now, I am going to discuss whether we can represent set or sets, or later on we shall discuss set operations diagrammatically, that means in figures. While we discuss sets operations and solve problems related to daily life, we use also diagrams. Generally, round, closed round figure or rectangular figure roughly are used to describe a set or sets. Roughly round figure, rectangular figure, or any closed plane figure are used in for the discussion of sets. Actually, we use those while we discuss set operations, also while we solve daily life problems. Next, we move to algebra of sets. Algebra of sets. First of all, union or join of two sets. Union or join of two sets. We take two sets as A, B. Then we will have a set, say C, which have members which either belong to A set or B set, and that is denoted by the symbol A union B, A union B, or A join B. Therefore, we can write A union B, that is a set of X which belong to A or B. Then union or join of two sets is another set having members of which some may be in A, some may be in B, or some may be within A and B. We express that by using Venn diagram like this. These diagrams were used by John Venn also by mathematician Euler. That is why we call these diagrams as Venn diagram or Venn Euler diagram. Popularly, it is known as Venn diagrams. Now, union of two sets. If A and B be two sets, then we express the union by this diagram, where we find shaded region is A union B. By Venn diagram we have expressed here, we have discussed here union of two sets A and B. This shaded region is the union. You see, there is a common part in between A and B. While we discuss union, the uncommon parts as well as the common part will be the part of the union of two sets A and B. We take example. Set A has members 1, 2, 3, 4. Set B has members 3, 4, 5, 6, 7. Then what will be A union B? Set of 1, 2, 3, 4, 5, 6, 7. That means members either belong to A or B or both. Thus, if I express that, what are the common members? 3 by putting dots. 3, 4 are the common members. Therefore, those are to be written in the common part. 1, 2, 5, 6, and 7. This is the A union B. Therefore, we have discussed union or join of two sets A and B. Next, intersection or neet of two sets. A and B are two sets, then their intersection denoted by the symbol this is actually inverted U, A intersection B, and that is a set of members X such that X belongs to A and X belongs to B. Therefore, intersection of two sets or neet of two sets is a set having members which are common to both A and B sets. For this example, we have taken A having members 1, 2, 3, 4, B having members 3, 4, 5, 6, 7. First you note what are the common members? 3, 4. Therefore, the intersection of those two sets A, B will be the set of 3, 4. This is the intersection or neet of two sets A and B. Now if we represent it that by Venn diagram, then this part which contains the members 3 and 4, that is the intersection of the two sets A intersection B. This shaded part having the members 3, 4 is the intersection of the two sets A and B. Thus we have discussed two, actually we call them operations, algebra of sets, that is operations of sets. We have discussed two operations, number 1 union, number 2 intersection of two sets.